So in this case, we are going to have a continuation on our statistics working with the grouped information that is the grouped data in that case. So if you are to consider on the grouped data, the difference actually is the presentation of the information. We are still having the same information, like you're given a certain information, but of that information that you are given, as we are having this word grouped, what is it that you refer as to group the information, to group the data that you're given? That is, you're given, let's say these are marks, so many marks that are given. Instead of us writing 1, this one got a 1, this one got a 1, another one got a 2, another one got a 3. There are so many in that interval. So we can simply write this as a class, not like what we had before. We can have it as maybe those ones who got 1 to 5. Those ones from 6 to 10, from 11 to 15. They are now being grouped in one class. So this is now a class to say 1 up to 5. 1 up to 5, how many are there? 6 up to 10, how many are there? 11 up to 15, how many are there? It's no longer an information which is direct to say if there is one, if there are those ones with 1, we just list them. We are listing. We move on to another one, 2 we list, we move on to 3 we list, like what we used to do. This time, it is supposed to be taken this way, from a certain part to another part, one part to another part. So it can be like that. So this is what I want us to do. I want us to understand what this class is all about before we move on to the calculating of the mean. It can be presented in different ways. Maybe they're writing the heights. The height is greater than 20, but less than or equal to 30, like that. It can be given that way. Still, it's an interval. It's an interval that you're given. So in these two, I want us to consider these two approach, because they can give us these two approach like this. All right. So we have what we call the upper class, like the whole of this is an interval, the class interval that we have, 20 to 30, the interval. But out of that, we have what we call the lower class boundary. So this is the lower class boundary. It is bounded, like the class that we are talking from 20 to 30. The class is limited from 20 to 30. So we have got the lower, and we also have what we call the upper class. These are boundaries. The boundary of the class is limited. So it's the same thing with this part. So within this, there are terms that you need to know before you talk of calculating of the mean. Out of this class that we are seeing, there are terms that we need to know, like the lower class, upper class, like the one that I'm talking about. We also refer to what we call the class width. The class width, the width of the class. The width of the class, because this is our class from 20 to 30. 20 to 30. So in this class, how big is this class? That is the width. How big is the class? Like the interval, how big the range from what you're given, how big the class is. Maybe if I put it this way, we are going to understand each other, how big the class is. So let's consider to say we are given this presentation like what we have. Let's say on a presentation of H being greater than A, but less than or equal to B, like what we have here. What will be the class width? Okay, I want you to see a simple thing in our mathematics, guys. I want you to see, maybe if let me put fewer values, the one that has got fewer values. Let me just work with 1 and a 5 like this. There we've got fewer values. There are so many values, but I'm going to explain this one after this one that has got fewer values. What does it mean here? It means H is greater than, it is bigger than, let's go back to our inequalities. H is bigger than 1. It is not at 1. If you are using a number line, if you are to present it on a number line as this is our axis for H, you're going to say that you have got your numbers 1, 2, 3, 4, 5. H is greater than 1. Talking of the whole numbers, you were not going to indicate anything at 1, but at 5, because H is less than or equal to 5, you're going to take that 5 to be part of your set. So if you consider, guys, the whole numbers that we're talking about, 1 is not involved. We're talking about the numbers 2 to 5. So how many numbers are there? 1, 2, 3, 4. This is the width of the class that we are talking about. There are 4 numbers. That is the width of the class. 1 is not involved. So it means if you're calculating the width of the class in this presentation, your class width is going to be the difference, 5 minus 1, which is equal to 4. You have the class width there. Upper class minus lower class. So I want you to be careful. This is a presentation of this. So in this presentation, if it is given like this, then our class width is going to be equal to B minus A, which simply means our upper class, let's just say upper class boundary minus the lower class boundary. Upper class minus lower class. That is how you can simply have your class width. But be careful, guys, because of this way, guys, I'm explaining this so that you understand me here, because you are going to see or notice a difference somewhere. So many say the same thing here. It was going to be 20 minus what? 20 minus 30, you're done. 30 minus 20, I mean, which is what? Which is a 10. The difference. 30 minus 10, like that. Which is what? Which is a 10. 30 minus a 20, which is going to give you a 10. That is your class width. But what about this type of a presentation when it is now taken? Okay, so this is our first one. The second one, we are now having H. In fact, H won't be given. They just give you A to B. This part, what does it mean? 20 to 30. Guys, it means 20 is part of the solution. 30 is also part of the solution. These two, they are involved. 20 to 30. So you don't subtract 30 minus 20 like that. Then you say there is a 10. This is wrong because 20 is involved. Okay, let me use the one with the fewer numbers so that you can understand me. 1 to 5 like this. It means 1 is there, 5 is there. 1, 2, 3, 4, 5. 1 is part of your set. 5 is also part of it. It's like this. This is what it means when it means 1 to 5. So you count your numbers 1, 2, 3, 4, 5. So the class width is going to be equal to 5. The class width, in this case, it will be 5. You involve, the 1 is involved. 1 is there. 1, 2, 3, 4, up and 5. They are out of that set. There it was H is greater than 1. 1 was not involved, this one. You are talking about 5 only. So it's 5 minus 1, you're done. So how do you find it now when it is like this? Because the moment you subtract 5 minus 1, you are going to get a 4. How do we get this 5? You are going to notice in this case, you subtract upper class minus the lower class. And whatever that you get, you must add a 1 when it is like this. So simply means 5 minus 1, which is 4. 4 plus 1, which gives you a 5. That will be the class width. Because 1 is involved, so you must add that number that you left out. When you subtracted, you are now adding it back. 20 from 30, meaning to say 30 minus what? 30 minus 20. Whatever that you get, you must add a 1. So this is going to give us a 10. 10 plus 1, which is 11. So the width of this class is 11. From 20 up to 30, you count even the 20 as a number. 1, 2, 3, 4, up to, you see there are 11 numbers. So be careful with the presentation that you're given. So in this case, if it is like this, then let's just say if this is 10, then the class width is going to be equal to B minus A plus 1. So you're going to add a 1 when it is like that. So it's B minus A, whatever that you get, you must add a 1. Meaning to say that is upper class minus the lower class plus a 1. In this case, there is an adjustment that you have to make. So you have to be careful. This part, it's also part of our syllabus. It's only that if you check most cases, you are given these questions that are presented that way. Then you just take upper class minus. So you won't see that. If they put a presentation like this, it is going to affect you. So you're going to see where we can have an example like that, where it is going to work. But these are some of the terms that I just need you to know before we talk about the mean. So that is the most important part. You have your class, whatever that you're given. Then you have to determine now the width. So this width or the class width, there's somewhere that we're going to use it. So you just need to know about this. It is information that is important here to understand before you talk of anything later on. The width of the class from the upper class and those lower class. All right, another part is on the calculation of the class center. The class center. So the class center is simply telling us of the center of the class. This is the center of the class, or just like class midpoint, the midpoint of the class, just like a midpoint in between the given numbers. So for the class center, I'm just going to write in short like this. Class center is equal to, you simply add the lower class plus the upper class. Whatever that you have there, you must divide by 2. That is the number in between. We're talking about the number that is found in between those numbers that are given from the boundaries. From the boundary of 1 to 5, the number in between. So if you know, guys, the number that is in between 1 and 5, 1, 2, 3, 4, 5. This is what it means. This is the number in between. The number in between. It is what? It is 3. This is the center. So if you actually can see that the number there in between is this, you can simply take that number between 20 and 30, in between 20 and 30. So to simplify that number, you add the lower class and the upper class, 1 plus 5, whatever that you get, you divide by 2. So 6 over 2, that is a 3. As you can see, we are having the same thing. So it is the number that is at the center from the presentation of those numbers. That is the class center. So these are some of the terms that are important that you're going to actually have in your presentations. So it is very, very important that we do understand these terms. So I want to go back to this part of our calculating of the mean from the class that we are given. I think we can have something there that we can put into consideration about the mean. All right, so in this case, I'm just gonna try to relate to this question that we are having here. Let me just try and have our question. There we are given some information, given the mass M in grams, the number of stones, and from this you're asked to calculate the mean. This is of the grouped information. So for you to have the mean, I'm just going to present this formula, guys. I just want you to understand even this presentation at your level now. You must be understanding some of these presentations. So I'm just going to write it this way. The mean is supposed to be taken from this formula. This sign here, it means sum of this one. The summation, it means sum, this one, sum of. So it is the sum of frequency times the class center over the sum of the frequency. The sum of frequency times class center. Sum of frequency times class center. That is what it means. Sum of. sum of frequency times class center. The sum of that, the sum of this. So we need frequency, we need the class center. The sum you add, sum means add everything. That is represented by frequency times what? Class center. Sum of that. Here, sum of F, it means sum of frequency. The sum of frequency to add the frequencies. So sum of frequency simply means we are talking about what? The total frequency. The total frequency. That is what it means. Total. Add. That is the mean. So this sign is just sum of. So if you understand it that way, guys, it's going to be easier for you to find this. So as we can see, we are talking of the class center. We are now back to these terms that I was talking about. You see now where we've been talking about this, the class center. So how do you find the class center? Lower class plus upper class divide by 2. Lower class plus upper class divide by 2. So on this example that we are given here, let's say the question is asking you to calculate the mean. Calculate an estimate. An estimate of the mean. So that is can be estimate of the mean mass that you're given, because this is the mean, the mass that you're given. So it can be an estimate of the mean mass. The estimate of the mean mass is simply the mean that you're calculating with this formula. Just calculate your mean as it is. So this is what you're going to have. So the mean, like I said from this formula, it is the sum of the sum, meaning to say we add frequency times class center frequency. Here, there is a frequency. The number of stones that we are given represents the frequent number of stones. Please remember number of. So we have got the frequency. And these are classes, 0 to 2, 2 to 4. These are classes that we are given, the class intervals. So meaning to say we need the class center of each. The class center of here. How do you find the class center? I said the class center. So there's no need for you to have a table showing that, guys. This one, you just use your calculator at once. There's no need for you to present that you're calculating the class center. No. This I just want you to know that. Lower class plus upper class divided by 2. So you've got the lower class plus your upper class, you divide by 2. Meaning to say the first one, we've got a 0. Upper class is 2. So simply, that was going to be 0 plus 2 over 2. Which is what? If you add these 2, that's 2 over 2, which is a 1. So the class center, there is a 1. The same thing here, you add 2 plus 4 over 2. 2 plus 4, lower class, added to the upper class. So what is it that we have on the lower class? That's a 2 plus upper class, a 4 over 2. From 2 to 4. That is going to be 6 over 2, which is a 3. So that is how you're going to have this. You have got your class center there, which is 3. The same thing, your class center here, 4 to 6. You add 4 plus 6, which is a 10, divided by 2, get a 5. 6 plus 8, which is 14, divided by 2, that's a 7. So you can calculate or determine these class centers. You don't need to show that. You don't need to be calculating them. There's something that you can even calculate by head, by using your calculator as well. There's no need for you to present that. There's no need. So with that, we can now determine our mean, because we need the product now. Frequency times the class center. Frequency times. So the frequency is 2 times x, the class center, which is what? For the first one, it's 1. Plus frequency. What is the frequency here? Frequency is 6 times the class center. What is our class center for this class? The class center is 3 from our calculation. Plus frequency, the third one, it's 5 times the class center there is 5. Frequency, that is 3. Because you're saying sum of frequency, sum of, this is the sum now, the sum. You're adding 3 times 7, like that. Frequency times class center, frequency times class center. Everything over what? The sum of frequency, the sum of which is the total frequency. You are adding sum of the frequency. The frequency as it is, you are just adding 2 plus 6 plus 5 plus 3. You add the frequencies that you are given. So that's how you can calculate your mean, just like that. So that is it, guys. You add up 2 by 3, you multiply. This is, you can just use your calculator to simplify everything. Okay, this was going to give us 66. Everything over what? You add the numbers. That's 6 plus 3. This one's going to be 8 plus 3, which is 9. And the total there, which is going to be 8. 8 and 8, which is 16. Okay. So that was going to be 13 plus, which is 16. Then you can divide 16 into 40. Can even reduce by 2, which is 8 by 2 here. That's 3, and that is 3. So 8 into 33, that will be 4 times. Okay, into 32. Then we've got a remainder of 1 over 8. So this is what I mean. 1 over 8, remember 1 over 8 as a decimal, guys, is 0,125. So this one can also be written as 4,125 as a decimal. That is the mean mass that we are given in what? In the grams, as we are given that this mass is in what? Is in grams. So the mean can be calculated, an estimate of the mean mark can be calculated from that way using the class center concept. You can calculate this the sum of, you add frequency, class center, product of it being added together. So you're adding each and every part, but having a product first, frequency times class frequency times. So even if you are given the presentation like it's written 0 to 2, 2 to 3, that part is not going to affect us. Okay. I want us to see something here. We still want to calculate an estimate of the mean mark. Let's say we are given a table like this, given the class, and this is our frequency. Just going to have a small table for that. We are given 1 to 5. The frequency is 2. 6 to 10. The frequency there is 4. 11 to 15. 7. 16 to 20. That is 5, and 21 to 25, which is what? Which is a 2, something like that. Then you're asked again to calculate the mean. So still, we're going to use the same concept. The class center condition. So it means you need the class centers. Frequency is already there. So you need frequency times the class. What is the class center? You add 1 and 5. 1 plus 5 over 2. So that was going to be 6 over 2, which is 3. So this is what you're going to do. The class center there is 3. So frequency times class center, 2 times 3, plus frequency here times the class center in between 8 and in between 6 and 10, that will be 8. You add 16, these two, 6 and 10, which will be 16 over 2. You have got 8 there. You do the same thing, guys, as you have been doing here. 7 times 11 to 15. You add, that was going to be 26 divided by 2, which is 13, plus frequency there is 5 times the class center from 16 to 28. It was going to 20. It was going to be 18. That is 36 divided by 2. The frequency is 2 times the class center from 21 to 25. That was going to give you a 23. You add 21 plus 22. 21 plus 25, I mean. Whatever that you get here, you divide by 2. Lower class plus upper class, divide by 2. Lower class plus upper class, divide by 2. Whatever that you're going to obtain there must be divided to the total frequency, the sum of the frequency. You add your frequencies. This is 2 plus next one, it's 4 plus the next one, it's 7 plus the next one, which is 5 plus the next one, which is 2. You add those frequencies together. That is the total frequency, the sum of the frequencies. So it depends. It's paper 1, it's paper 2. Combine this. If it is paper 2, just use your calculator to simplify everything. You're going to obtain 265 over 1. The sum of these, which was going to be a 20. So this was going to be 13 and 1 over 4, which you can also write as a decimal, 13,25. So that is what you're going to have. So make sure that you combine properly, multiply properly your numbers, add properly, addition. I think that part can be for you to work on. Try to do as much revisions as you can. So this part that we are having, it is calculating mean and estimate mean from this formula. Sometimes this is what they are going to do, still calculating this mean, but this formula now is no longer to be used. So this is the part where you are going to calculate an estimate mean or to calculate a mean given the assumed mean. So that part is part of your syllabus. You need to know it. Never neglect that part of calculating mean using or given as assumed mean. Given assumed mean. So calculating mean this time, you will be given the assumed mean. Okay, that is the assumed mean in that case. You are given that. So how do I calculate a mean on this condition? Calculating mean given. All right. Where is this particular is coming to given? Given assumed mean. How can I calculate that? The mean can be calculated as the assumed mean that you are given. So we are going to use this formula. That is the assumed mean plus the mean deviation. Plus the mean deviation. So assumed mean is something that you're already given, this one. But the mean deviation, you are not given. You are the one who is supposed to calculate that mean deviation. So what is the mean deviation? Where the mean deviation, this mean deviation, where the mean deviation is equal to, you're talking of the mean deviation now. How do you find it? It is the sum of, now we are used to this, so I'm going to repeat this symbol. It is going to be taken from the sum of frequency times deviation. Frequency times deviations. The sum of that, sum of frequency times deviation, okay? Over the sum of the frequency, the total frequency. So these formulas, guys, now get used to these formulas. I want you to get used. So this is simply means what? Sum of frequency. Okay, I'm just going to write it in short. Times deviation. Sum of, you add the total of this, the total of frequency. Meaning to say you must find frequency times deviation, you add them. Okay, this is simply the total frequency, this one, total frequency. So this is how you calculate your mean deviation. So where D is the deviation, this one, the D is the deviation, D, deviations. D represents the deviations. I'm going to show you on the calculations. So the deviations. So how do you find that deviations? And D is equal to, that is this deviation, it is equal to the class center. It is equal to the class center minus the assumed mean. Minus assumed mean. All right, so these are the formulas that we are going to need to calculate this mean from the assumed mean. So D, remember, this is your deviations. Class center minus assumed mean. You'll be given that. You'll be given information about that, where you need to find the mean from there. So with these formulas, guys, I want us to put them into practice. Let's say we are given a table. Like I said, this will be using the assumed mean. Okay, so let's say we are given an example. In that case, you have got a table that is given the class and also the frequency. You want to see how we can determine this. And from these classes, these are classes given randomly. 1 to 10, 11 to 20, 21 to 30, 31 to 40, and 41 to 50. Let's say this is what you're given, and the frequencies is 2, 4, 4 again, 9, 1. This is your information. And with this information, you are given you'll be given the assumed mean. That part they will give you. So given the assumed mean, given the assumed mean equal to 20,5. Given the assumed mean equal to 20,5. Calculate the mean. Calculate the mean. Once you are given such statement, it means you have to use this method. Unless it's an exam condition where they will give you a table to fill in one way or the other, you won't escape that part. If you are given it under exam condition, you have to approach that. So this is what you're going to do. You're going to have a table like this, okay? You want to calculate the mean, remember? And that mean is supposed to be taken from this formula. Assumed mean plus what? The mean deviation, where the mean deviation is taken from the sum of the frequency times the deviations. So all these must be part of our table. So we are going to have our table this way, all right? So let's save our solution. So this is what you're going to do. Under exam condition, they will fill in some of the other parts of the table because of the issue of marks. Because if they give you a question like this, they want you to calculate the assumption. There's a lot of things that you have to calculate. So avoiding now to give you maybe 12 marks or 8 marks for this type of a person, they will fill in some other part of the information. But the table that you're going to have can be related depending with how you're given. But what is important is for you to have the class, center. Okay, on that table, you need the class center. All right, so I'm just going to write, say C for the class center. All right, you are also going to need the frequency as we have there. F is our frequency, remember? That is our frequency. You are going to need, we saw that there, the deviations, the D representing our deviations. All right, so I'm just going to write D, meaning this is the part of our deviations. The D is the deviations. Then we are going to need the sum, as we saw from the formula there, the sum of frequency, this one, the sum of frequency times deviation, meaning to say we are going to need that. So let's have another column just for frequencies multiplied to the deviations because we need their total. So this will be frequency times deviation. So we need their total. So we must see that part so that we can simply add them just like that. So this is what you're going to have. All right. So let's have our classes, guys, as they are here. 1 to 10, this and that. All right. So the first class, what we have is the class of 1 to 10. This is what we can tell. It's 1 to 10. And the frequency there is 2. All right. The other one, it's 11 to 20. 11 to 20. And the frequency there is what? The frequency is 4. Okay. So this is what we can feel right now. The class and their corresponding frequency. 21 to 30. 21 to 30. Corresponding frequency is 4. Okay. So these ones, we can feel them. We have that information corresponding. So meaning to say, we can easily feel that information. All right. So we move on to another one. 21 to 30. The other one, 31 to 40. 31 to 40, and so on. 31 to 40. That was a 9 there. That was a 9. The frequency. And another one, the last one, it was 41 to 50. 41 to 50. and the frequency there was a 1. So this is how our table actually is going to look like. Like I said, they can present this table in different ways. They can present it in different ways. But as for you, the basic understanding, it is supposed to be like this. Okay? They can give you this table differently presented in the way that they want. But this is what you need. So this is the part that you need. So like I said, you need to fill in here. So there'll be a lot of things now. So they will try now to fill in some of the other parts that you're given. They will fill, then they'll just ask you maybe to fill in what is missing, maybe this part or this part or this part. So that at least the issue of marks, because each part that you're going to fill, it's a mark. So remember, this is supposed to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this question is going to actually take all the marks in exam. So they won't do that to give you a question like this. They will give you a certain part being filled in. So you have to understand it as it was not given, because for you to fill in, you must understand where it was taken from. So these are simply class centers. So remember your class centers. How are you determining the class center? Lower class plus upper class divided by 2. This one is not going to change. 1 plus 10 divided by 2. 1 plus 10 divided by 2. That's 11 divided by 2, which is 5,5. 11 to 20. 11 plus 20 divided by 2, class center. So that was going to be 15,5, and so on and so on. 21 to 30, you add, you divide. That was going to give you 25,5. Another one, 35,5. And another one was going to give you 45,5, like that. Upper class and lower class divided by 2, or lower class plus upper class divided by 2. You have your class centers. Then what is it also that we need on this table? The deviations. There's a column of deviations. And how do you determine this? All right, this one is for the total frequency. You can simply add 2 plus 6 plus this. This was going to give us a total. This one is the total. This is the sum of the frequency, the total of the frequency. You add these frequencies. But here there's a need for the deviations, the D, where I said, how do you determine deviations? D, the deviations is class center minus the assumed mean. So class center minus the assumed mean. The assumed mean. The class center minus. So you simply sub this one, the deviation, this one. The class center that you are given there. What is your class center there? So D, class center minus what? Assumed mean. Minus assumed mean. What is it that you have? The class center is already there for the first one. The assumed mean is not going to change. Remember, we are given that. Given assumed mean to be 20,5. So we are given this part here of the assumed mean here is given is 20,5. So it is simply class center minus 20,5. So the first one, 5,5, that's our class center there. So it's 5,5 minus 20,5. The difference, 5,5 minus 20,5, that is minus 15. You do the same thing, 15,5 minus 20,5 is everywhere, every part. 15,5 minus 20,5, that was going to give you minus 5. 25,5, class center minus assumed mean. You subtract throughout. That was going to give you a 5, and so on. 35,5 minus 20,5 on this one. You get your assumed mean like that. I mean, you get your deviation. So this was going to be a 15. 45,5 minus 20,5 was going to give you a 20. That was going to be a 25, this one. So the reason of choosing or being given an assumed mean, which is a decimal, is for you to have at least whole numbers here. So they are going to give you an assumed mean, which is proper to whatever that you're given. So like I said, you'll be given, when you're not given, then you just choose your own assumed mean, like to say which one that can be our mean. But in most cases, guys, we are given this, so do not worry about that. The frequency times deviation, this is the last part here. We simply need frequency. It's as it is, guys. F times D, the product. frequency times, you multiply this. Frequency times deviation. Remember, this is your F and this is your D. So it's 2 times minus 30, which is 2 times minus 15. 2 times minus 15. That is minus 30. 4 times this, you multiply. 4 times minus 5, minus 20. 4 times 5, which is a 20. 9 times 15, which is 135. 1 times 25, which is 25. You multiply frequency times deviation. Frequency times its deviation corresponding in that class. Then we need the sum, as we can see here, because the formula there, it states that we need the sum of what? Here. Frequency times we need, it's just like the total frequency. We also need the sum of this. So we are simply going to add this one. Because already we can see this is our frequency times deviation, this one. But what is the sum of, like I said, the sum, add frequency times deviation. What is the sum of these? You add these numbers, you add them, these ones, you add them. Minus 30 plus minus 20 plus a 20 plus 135 plus 25 you add. So that was going to give us a total of 130. Be careful with the directed numbers. They are negative there. Minus 30 minus 20 is minus 50. Minus 50 there, that is what you get. Then you can add minus 50 plus 20 plus this, you get 130. So this is the total of the frequency times deviation, this one. We are filled in our table. So like I said, sometimes you're given, they'll give you a piece of a table field, then you complete it. So after completing like this, they will now say hence or otherwise calculate the mean. It's up to you now to go back to the hence, to the otherwise method, the one that we used before, or the hence method, the continuation from the table. When it is like that, you are continuing with what? This part, and we have to continue from this part. That mean is equal to assumed mean plus the mean deviation. We have the assumed mean, but we do not have the mean deviation. So we must find the mean deviation first. How do you calculate mean deviation? Sum of the frequency times deviation over sum of the frequencies. We talked about this. So it's already there on our table. So it's already there. So this is what we need first. So let's start by the mean deviation. So from this table, our mean deviation can be calculated. Remember, the sum of the frequency times the deviation over the sum of the frequencies. So it's already there. Frequency times deviation, the sum here, frequency, the sum. What is the sum? The sum, it is 130 over the sum of the frequency, the total frequency, that is the sum of the frequency. When you add these frequencies together, their sum, what is their sum? The sum is 20. The sum of, this sign here means sum of, you add those ones. So that was going to give us a mean deviation, 6,5. You have got what? The mean deviation. But the question is, we do not want the mean deviation. We want the exact mean. So what is the mean now? As I said, the mean is going to be assumed mean plus the mean deviation. Assumed mean plus the mean deviation, of which the assumed mean, we have it now. We have it, we are given. Remember, that is the one that you were given before. Assumed mean is what? 20,5. So we are going to take that assumed mean that you are given, 20,5 plus the mean deviation. What is your mean deviation? 6,5, the one that you calculated. With this, you are going to obtain a mean of 27, which is exactly the mean that we could have obtained if we are using the normal way of calculating our mean, where we use class center times frequency. Those, we're going to have the same answers, but this one is calculated from the mean deviation. So under exam, like I said, sometimes you'll be forced to use this. You do not have a way unless they have to specify to say hence or otherwise. On that case, you can opt for whatever that you want. So never take the part of mean. for granted, because this part can be asked where the mean deviation has to play a role. All right, so I want you to see a typical exam question so that we can simply finish up. For those who will be trying these questions, you can at least try them with something that is applicable. All right, no, this one is not the one that I want. I think I had PDF of that. So let me just bring one or two questions that we can actually relate to this information that we are given. So if we check here, there's a question that we can actually work with here. They gave us, it's a typical exam question where this is to be taken. I want you to see this. So there will be a condition like that. So they were given the table, shows the distribution of marks obtained by 30 peoples. We are already told there are 30. The total of number of peoples there is 30 in a class test. So you're given the mark, and this is what you are given, the number of people showing what? The frequency. The table shows entries used to calculate the mean of the data using an assumed mean of what? 12,5. We are given here the assumed mean of 12,5. You are given that. And the question here is that you're given is some of the information is placed here. The class centers, as we saw, here it was supposed to be like what? From our table, we had only this part that was showing what? That was showing the classes this side. The part that was showing our classes here. So guys, we're not gonna have that part. Like if they did not present it to say the class, this is what you know. This is what we have. Like the mark that you're given 1 to 5. Those are the class center. Those are the classes. 1 less than x less than or equal to 5. So it was supposed to be having the classes, but like I said, you use the table the way that is given. So if that part is not indicated, know that it's supposed to be these class centers are taken from the classes. So you calculate from each class here 1 to 5. How do you find your class center? Remember our class center, lower class plus upper class divided by 2. The lower class, 1 plus 5 divided by 2. So that was going to give us a 6. Then we divide by 2, which is 3. This is where the 3 is. So this is it, 5 to this one to this one. They calculated. So the missing part here, if you check, is the Q. We do not have that. But it's the class center. So for which class? If you check, this is second from last. This is the last class. So from the second one from last, this one. This is the one that we need. So they did not give us this one. We need to calculate each class center from 15 to 20. So still the same way. 15 plus 20 divided by what? Divided by 2. That's our Q. The class center of this class. 15 plus 20 divided by 2. So that was going to be 35. If you add, divide by 2, which was going to be 17,5. The center there. So Q, we have it. 17,5. So we're just filling in our information there. We are just filling in. So this will be 17,5. So that's what they were asking you to calculate these values, P, Q, R, S. Calculate that. All right, so let's consider another part. There's P here. What is P representing? Remember, here, according to your diagram here, they are saying F into the bracket of X minus. This X minus 12,5. It is the X for class center minus what? 12,5 is the deviation. So when you say X minus 2 is the part representing the deviation. This part here is for the deviation. This one. This is your deviation. That's the part of your deviation, the part of the D. Remember from our deviation concept. So this is the deviation D. So here they're simply saying F into this bracket. They are simply saying F times D here. F times D. Frequency times deviation. Frequency times frequency. You multiply frequency to the deviation, you get this. Frequency to the deviation, you get this. Frequency to the deviation, you get this. Remember what I was presenting in our previous example. This is the part that we are talking about. So you must now analyze according to your diagram. So P is simply the product of this 8 times minus 5 is what? That's our P. 8 times negative 5, which was going to be a negative 40. So that was going to be a negative 40. We've got a negative there. So that's a negative 40 there. So that's how you can have this. Okay, let's check another part. What is it that we need? We need the R in this case here, which is the deviation. Remember, deviation. X is the class center. Deviation, it's class center minus assumed mean. So already they wrote that assumed mean there. X here, this is the X here. X minus. So you're simply going to take your R to be what? X class center 22,5 minus what? Assumed mean, which is 12,5. X minus 12,5. So that was going to be a 10. So this is a positive 10. Yes, you can see they wrote in terms of the sign. So you can just write positive 10. So that's 7 times 10. That's a positive 70. What about S? Is the total here, like this total frequency, they calculated. So this is the total sum of the frequency, which is that. They calculated this S here. It's the sum of the frequency times the deviation. Frequency, this one, you add. Minus 38, you add to minus 40. You are adding this. Minus 40 plus a 0 plus a 30 plus what? A 7. You add. So that was going to give us a 22. So you see, you filled in your table. You have calculated these values, not actual to fill in, because they wanted you to calculate. So you have to calculate. So you have P, Q, R, and S. And from there, they are now saying hence or otherwise. That is where I was saying now. Hence, it's a continuation. Otherwise, you can opt for any other way that you understand. But hence, it's from this table using the assumed mean. Continue like that. Now calculate an estimate of the mean of the distribution. So how am I going to calculate? Using this one, the formula of the assumed mean. We said the mean is going to be what? So I'm going to focus with the hence. It's a continuation. So from there, our mean, remember I said it's going to be assumed mean plus the mean deviation. But we do not have the mean deviation in that case. So we must calculate the mean deviation first, where the mean deviation is the sum of the frequency times the deviation over the sum of the what? The frequency, which is this as the total as the frequency times deviation on this column. Their sum. What is their sum? The frequency times deviation. The sum is what? Is 22 over the total of the frequency. Under the frequency, what is the total there? The total is 30. So 22 divided by 30 was going to give us 0.733 to 3 decimal places, to 3 significant figures. In fact, this is paper 2. So you can use your calculator. Then from there, you can now calculate your mean, where the mean is the assumed mean, the one that you are given. Remember, you're told that the assumed mean is 12,5. So you're going to add 12,5 to the mean deviation, the one that we are given, 0.733. So that was going to give us the mean now, which is 13,233. That becomes the mean. Using this table and using the concept of the mean deviation. Calculate your mean deviation, then you calculate your mean. Assumed mean plus mean deviation. So it can be like that. All right, let's say we want to use the otherwise method because you filled in the information, everything is there. And you want to opt for the otherwise. Now the otherwise is where you can use that formula now. Where you can now opt for, that is another way. Remember, how were you calculating the mean from the first formula? I said mean is equal to what? The sum of the frequency times the class center over what? Sum of the frequency. Remember the first one that we did. Frequency times X, I said X is what? Class center. Frequency times class center. So using this formula, guys, you already calculated these class centers. Remember here, these were class centers. And these are the frequencies. So it was simply going to be frequency times class center 4 times 3. That's another way. That is the otherwise method. Frequency times class center. You add sum. You need sum of 8 times 7,5. Plus, you move on, 5 and 12,5. You're adding 5 and what? 12,5. 5 times 12,5. You move on to another one. Frequency times class center 6 and 17,5 and so on. 6 and 17,5 plus 6 times 17,5 frequency times class center, frequency times class center and so on. 7 and the class center 22,5 plus 7 times the class center 22,5, just like that. So this is how you're going to end up with your what? With your mean again in the same way. You're going to have the same, in this way, you're going to have the same answer. So over what? Sum of the frequency, the total frequency. What is our total frequency already? It's calculated. You're not going to start 4 plus 8 plus, guys. Already there on the table is what? Is 30. Total there is 30. So that is it. You're going to have your mean. So you combine this, use your calculator. This is paper 2. That was going to give you 397, everything over 30. And as a decimal, 13,233. Okay, if you want to use the 3 decimal place there at the end. So that is how questions can be like. That is how questions can be like under exam condition, where now you have to opt and work with information that you are given. It's an exam. You have to work with the question, how it is given, the instruction, the degree of accuracy. It's all about the instruction that you are given there. So you just have to be careful on the presentation of whatever that you will be given. And also on another part of our exam, this is just going to be the last part to consider. There, I think everything. Just summarize, talking of the mean, mode, and everything. The table below shows heights, age 50 trees in a school. Write down an interval which contains the modal height. So as we had before, we are talking of the mode, mean, median, this and that. When you're dealing with the ungrouped information, this time they will be talking of a modal. It's like the modal class. It's a class that must have highest frequency. Remember, I said mod is the number with highest frequency, but this time it's a modal class. Which one is got highest frequency? 16. We talk of the class there. The class H is greater than 6, less or equal to, as it is presented. You are now writing it as a class. The median height, remember the median height, when you're talking of this median, I said the first thing is to determine its position. The position of what? Of the median, where the position of the median is taken from half of n plus 1. Where n is the total frequency, you add the total frequency. How many terms are there? These ones you're going to add and get a 50. So it was going to be half of 50 plus 1, which is 51. Half of 51 is 25,5. It's a position. Where are we going to get the class in this position? So if we add 12 plus 16, that's 28. You have already exceeded 25,5. So it's appearing in this class. Okay? 10 plus 12 that's 22. We are still less than this one. We are at 22. We are less than 25. So if we add the 16, 22, guys, if we add this, we have already exceeded these 25,5. It's above that number. So just check the ungrouped data, guys, about the median, how to calculate this so that we do not waste much time. So it was going to lie in this interval of h is greater than 6, less or equal to 8. So just try to go through ungrouped information where I explained much about this so that it does not take us our time much. Then the mean, as we said, guys, the estimate of the mean, we need the class centers. We saw this. So this one, I think, guys, it was just going to be you walk over the mean frequency times class center. Remember the sum of the frequency times class center over the sum of the frequency. So we need frequency times class center. 12 times, what is the class center from 2 to 6? 2 plus 6 over 2. That is 8 over 2, which is 4. So frequency times class center. Frequency, 16. The class center, 6 to 8. You add 6 plus 8, divide by 2. That was going to give us what? A 7. That's 14 and 7. Plus frequency times class center from 8 to 10. That's divided by 2. 18 divided by 2, which is 9. So that's 12 times 9. Plus and so on. 10 frequency. The class center of 10 to 12, it's what? It's 11. That one is 11. Everything over the total frequency you add. They are already given. We are already given that there are 50 trees. There are 50 trees. So there's no need for you to add. Just write a 50 there. So that's it. Multiply everything, guys, on top, add. That was going to give you 378 over 50. And this is going to give us 189 over 25, which is 7 and 14 over 25, or 7.56 as a decimal. So this is what you have under the grouped information, talking of the mean. Mode can be part of the median height or the median class that you're given. This is how questions are going to be like. You just need to work with more questions as you are revising. So we shall meet again in another class. Now talking of the presentations of these statistics, how to use the graphs now to present our information. So you need to work with more questions as much as you can.